to start on the next set of videos where we dive into some data that is from the building industry to give a sense of how to solidify some of the techniques and understanding of the functions of the Seaborn library that we've learned previously, but in the context of buildings. So there's a data set that we're going to look at that is, there'll be a link that's provided. It's one of the data sets on my Kaggle platform page, where it's essentially a data set of thermal comfort data from buildings, from indoor observations from various research studies across the world over the last few decades, in fact, of this type of research or data. This data set is an open data set that's been worked on by a large group of collaborators you can learn more about in the metadata portion of this data set. I've gone through and created a couple notebooks to illustrate some of the visualization techniques that you've learned so far on a data set that's from this context. To learn more about the data set, there is a data source, there's an abstract here, methods, usage notes, funding, etc. There is an entire publication that you can check out if you're interested. That should be open access from and led by the University of California, Berkeley team from the Center for the Built Environment, where they basically did most of the work to collect these data from lots of different people from around the world and aggregate it and make it into this nice data set that people can use to explore. If we come down here to the bottom to the Data Explorer, we can see that there's only one file. It's not even a massive file. It's 53 megabytes. And you can see that each of the columns has different meanings. Here's a key. But also these data have been put into the data set here. So you can see the names of the columns and what they mean. You can see an aggregation of where the data is from. For example, here's the time range. The data comes all the way from 1979 all the way to 2016, 2017. There's lots of metadata, and this whole data set, there are 70 columns. There's quite a few pieces of information about each of the observations here, and there are over 80,000 observations. And each of these observations is a measurement of indoor air conditions and environmental conditions, and then feedback from an individual person, usually a test subject in a research case study or a research lab-based study. It's a person who is given information based on how they feel in a certain space at a certain time in certain conditions. We'll dive into this as we look at the data from this data set. If you go into code, you can see the notebooks here. You can see that there's a bunch of notebooks that people have been working on to process these data and answer various questions. I have a notebook called Seaborn Demo, which I'm going to show in this video. And so let's just dive right in. If we pop over to that notebook, you'll have to copy this version of this notebook into your Kaggle account to get started with it. So I've already done that in my own account here. You can see a little bit of an introduction to what this notebook is all about. We're basically going to dive into some of these observations to visualize and analyze indoor environmental quality data or thermal comfort data specific from this database. So here I repeat some of the links that were found in the data set. Here's a copy of a PDF of that journal publication where you can learn more about this data set if you'd like to dive into more information. The goal of the notebook is to really start processing and understanding and analyzing the data set itself. So first things first, we go ahead and load the library. We go ahead and load the single file that we have here, which if you look over here on the side, you'll notice, of course, we've got the data set itself that we can use. There is an attribute we're using here because of the certain features within the data set. We need to indicate that we want to turn off the low memory warning, which will get a warning if we don't do that. I don't want to go into detail. That's a more advanced topic, but for this particular data set, we can avoid that warning by indicating that attribute. So let's take a look at what's inside. Let's look at the first 5 rows. Here you can see, like we saw in the Data Explorer for Kaggle, we've got things like publication that the data came from, the name of the contributor, the year, the season, the climate, etc. There's dot right here in the middle, which means there's quite a few columns that we're not seeing. And then the end columns you can see are things about the subject and various metadata about the building. Let's use .info. I like .info because it gives you a full range of the columns. Here are the 70 columns. We can see that there are, in fact, over 100,000 entries. Instead of 80,000, there's over 100,000. And I believe that's because there's 80,000 entries plus the original ASHRAE Thermal Comfort Database 1, in fact. You can see over here the non-null counts. Quite a few of the fields or columns have most of these attributes. Some of them don't have quite as many. For example, age, not only 43,000 of the samples have age. You can skim through and see that there are quite a few of these, especially as you go down the list, that are not, they're fields that are not available for all of the points. One of the first things that we'll look at before we dive into the visualization stuff is a little bit more about the summarization of data. When you have data sets like this is essentially a bunch of data from a bunch of people. And anytime you collect data from this type of population, you're going to get a range of behavior. It's never just black and white. There's never one right way or wrong way. There's a range of behavior and responses and the way people give feedback. Some of these are going to be a bit of a review. We're going to see some of these in previous courses, but we'll look at them in the context of this data set. So once again, first .info is quite straightforward. There is a function called .describe, which we learned a few lessons back, where we're looking at each of the columns and getting a sense of the distribution, the count, the mean, the standard deviation, min, max, and the different quantiles. Here you can get a sense of, okay, what are the values of these different things? And if you wanted to statistically characterize these columns with a subset of values, these would be the values that you would use. You notice that the function automatically excludes columns that don't include float data types. You can't take the mean of a non-numerical value. That's one thing that Pandas does for you quite usefully. You can, of course, take the sum, you can take the mean, the standard deviation. This is a review of what we saw before. We can look at the diversity of data through the .info once again. We can look at the length of data, which we can see also from .info. We can see the number of unique values in certain columns. So how many countries are there in this data set? In fact, there are 28 different countries represented in the data set. Once again, value counts. In this data set, we're going to see that for country, where most of the data, what are the countries where a lot of data comes from? The UK, India, USA, Australia, China, Brazil, Pakistan. So you can see the top basically list of countries that it comes from all the way down to Philippines, Denmark, Belgium, which have the least amount of data. You want to look at what are the types of buildings that are in here. This is really nice to explore this data set. We've got mostly office buildings. We've got quite a few classrooms, quite a few multifamily housing, other types of buildings, and senior centers. So it's not a massive range of building use types. Offices are the main target of this type of data. We look at climate. What are the different climates? We've got quite a bit from hot Mediterranean climates, humid subtropical climates. You can see what the diversity there is. What are the people's self-identified sex attributes? So you've got more males versus females in this data set, but balanced, relatively close, I would say, but slightly more, 6,000 more out of the data set. What type of cooling system was used in the data set? You've got naturally ventilated, you've got air conditioned, mixed mode, mechanically ventilated. What are the primary years? Most of the data, a lot of the data came from 2012, it looks like, and some from the mid 90s. And then seasons. We've got quite a bit from summer and winter and less from autumn and spring. So we'll take a stop here. In the next video, we'll dive into other ways that we can start processing the data frame.